Today, chapter 7, section 4 is special right triangles. So there are two, like we already know that right triangles, we've got some special things, like we've got Pythagorean triples. Those are really nice because we can help find the sides. But there are some certain triangles that are so useful that we bring them into Algebra 2, and they help kind of found the foundation of the hardest things in Algebra 2. So those of you who kind of hang on to today, when you get to Algebra 2, you'll be like, oh my gosh, I actually do remember this from geometry. This is going to help me out. So you're going to see this again. So let's talk about special right triangles. The first special right triangle, we're only going to talk about two. There are only two that we cover in geometry, and the first one is called a 45, 45, 90 right triangle. Called that because its angles are 45, 45, and 90. So in a 45, 45, 90 triangle, the hypotenuse is the square root times as long as each leg. Now don't worry, I'm going to break that down into English here. What this means is that when you have a 45, 45, 90 triangle, meaning that the angles are 45, 45, and 90, something special happens. It will always, always, always be the case that the legs are congruent. Why? You already know the answer to this part. Yes, sir.
Because like when you have like those two the same, like you do it to like the side that's opposite to it.
Easier way than I think where we're going there. Look at those two angles. You might actually have to rotate your head. Actually, it would probably help you a little bit if I might give it away. But if I did it like this, you might see it a little easier. But only because I marked it that way. Like I put those two lines there saying it's congruent. What if I just saw that 45 and 45? How do I know that those two legs are congruent? We've gone over this. The what? Yeah, well, so the converse of the base angles theorem. Right, so we've got that. It says that since those base angles base angles are congruent to each other, it must mean that the legs are congruent to each other as well. Like this is an isosceles triangle for sure, and that will always happen in a 45, 45, 90 triangle. Those legs will always be equal to each other. If one of them is 10, the other one's 10. If one of them's 1 million, the other one's 1 million. But take a look at the hypotenuse for a minute. Notice that they labeled the hypotenuse as a times the square root of 2. That a that they're talking about is this right there. So let's pretend that a is 10. I'm just making this up. Let's say a is 10. Well then, what is the leg at the bottom? 10. It must be 10 as well. Then, let's say I only knew that leg. Well, the hypotenuse would be 10 times the square root of 2. You take whatever that a is, whatever that leg is, and multiply by the square root of 2. Just take that number, 10, and multiply by the square root of 2. Inside numbers times inside numbers, and outside number times outside numbers, and we get 10 square root of 2. The length of the hypotenuse is 10 times the square root of 2.
And you can't do anything with that?
So you will, the A will always be outside?
The A, well, I'm going to give you some different examples, so I shouldn't say always. Let me give you a couple easy examples first, and then I'll give you the hard examples right afterwards. I'm going to draw that exact same triangle there. So I'm going to draw it in the exact same way. You could rotate it, it doesn't matter, it doesn't have to be drawn this way, but just since we're just learning it. And notice that I did not draw the last angle, but how do I know that this is a 45, 45, 90 triangle? Why not something else in that other corner?
Because they have to add up to 90.
Yeah, the triangle sum theorem says that it has to equal 180, and right there is 135 of it. There's 90 plus 45, which means the last one has to be 45. Okay, so I'm just going to make up a number here. I'm just going to make something up. Here's a leg that is 8. From that information there, I can tell you all the sides of this triangle. You want to give it a try, Joe?
You can know that the other, like the one on the bottom is 8.
The other leg is 8.
And then the hypotenuse, right, is 8 square root of 2.
8 square root of 2. So notice just by giving him that one piece of information that one of the legs was 8, he was able to complete this triangle. Now, if you don't believe me, you could actually plug this into Pythagorean theorem and check it. 8 squared plus 8 squared will equal 8 square root of 2 squared. I know. It doesn't feel like it, but
What?
what I'm saying is that if you're like, I don't think that sounds right. Let's say you're like, you do this in a homework problem or something, and you're like, this doesn't sound right. Let me just check this with Pythagorean theorem here quick. 8 squared plus 8 squared is equal to 8 square root of 2. That's
right.
well, because we already know in a triangle, a squared plus b squared, in a right triangle, a squared plus b squared is going to equal c squared, right? So this should be true, yeah?
But how do you do the math of that?
Okay, so let's see. This is what by the way, the people who struggled on the quiz, this is one of the things that they struggled with right here. Not this exact numbers, but what is 8 squared?
Oh.
64 plus 64 is equal to, now this is the part that people struggled with. How do I do this?
Oh, I remember. You just do two of them. Like you do 8 times the square root of 2 and then another one.
Okay, so this is 64 times the square root of 2 times the square root of 2 is the square root of 4, right?
Which is 2.
Which is 2, so it's 64 times 2, which is 120. Which don't you like? You just told me to. This is what you told me to do.
Oh, that's crazy.
So this is all we did was check it just to make sure that that is in fact true, and it is true. Like if these are are those three numbers a Pythagorean triple? No, why not?
Because it's not a whole number.
Because one of them is not a whole number. One of them is 8 square root of 2, so we can't use that.
No, now it's 8, now it's 128.
Now, I'm going to give you a big hint. Those of you who choose to listen to this big hint will understand the next problem better. Here's how Gio knew that this was 8 square root of 2. Now, you may already understand, but I'm giving you a big hint when I tell you this. He took the leg and he multiplied by the square root of 2 to get the hypotenuse. Keep that in mind because I'm about to give you a situation that we haven't dealt with before, but I'm guessing you can figure it out.
Deal to 10.
Yeah.
Because 10 is the 8.
Oh, it's 10.
Okay, so you guys aren't wrong. A lot of people are saying, hold on a second, hold that thought. I want to get back to that. A lot of people are just saying, it's 10, I can see it's 10. And they're not wrong, but that's because I gave you a super easy one that you're not going to be able to get as easy as soon as I draw the next one. I'm going to give you a hard one after this. But let's talk about it. Gio, what were you about to say?
You don't know that it's 45, 45, 90.
Oh, I'm sorry. I meant to do that. My apologies. You're right. I'm sorry. You're right. So now here's what people are saying. The leg must be 10 because it's that number times the square root of 2. So you're like, it's a times the square root of 2, so this must be 10. Okay? So check it out. I am going to give you a problem that's going to be way harder for you. Yes?
I have a question.
Yep.
So, say you have a 90-degree triangle, or a right triangle, and you have like the hypotenuse is times the square root of 2. Does that mean you know it's going to be 45, 45?
No. No. We can only do all the things we're doing because this is a 45, 45, 90 right triangle.
Okay, so it doesn't work good. Like if it's like say.
I don't want to say, if I know all the numbers, there's a way of telling whether it's a 45, 45, 90 right triangle, but I'm not ready to go there yet. Okay, here I'm about to make this way harder on you.
You'd have to divide it by the square root of 2.
Oh, I love what you just said. Go back a second. A moment ago, I told you that if you have the leg, you multiply by the square root of 2 to go to the hypotenuse. So guess what you do to go back? You divide by the square root of 2. Now this is going to get ugly, so stick with me. To go from here back to the leg, we have to divide it by the square root of 2. Because think about it, we had to take the leg and multiply by the square root of 2 to get here. So to go back to the leg, I need to divide by the square root of 2. But there is something totally wrong with what I just wrote right there. It's not wrong, I didn't trick you. It's just that is not an okay answer. Why is that not an okay answer?
Because it's a square root and it's not a whole number.
Well, we've got a radical in the denominator.
Oh, yeah.
We're not allowed to have a radical in the denominator. So how do we fix it?
You do negative square root.
You cancel the thing out.
Sounds like we're just grasping at straws there. We need a way. We did this before. Not by 2. Okay, so check it out. For those of you who are struggling, check it out. If you want to get rid of a radical, a square root in the denominator, whatever is, hold it. Whatever's right here, we're just going to multiply by that on top and bottom.
That's smart.
Let me show you what happens, and then you'll get what happened. Oh, sorry. I wanted that to be red. Okay. That thing on bottom is what we didn't want. So I'm going to multiply by top and bottom. What is the square root of 2 times the square root of 2?
2.
Is the square root of 4, and the square root of 4 is 2. Notice that problem has taken care of itself.
Then what's the top?
Now the top, 7 times the square root of 2 just ends up as 7 times the square root of 2. And we end up as 7 square root of 2 divided by 2. I'm about to make a huge mistake. Understand that this answer is good right here. And right now, at this moment, I'm about to make a huge mistake. I'm going to cancel this 2 with this 2, and that just equals 7.
It's not a square root on the bottom.
Inside numbers can be divided and multiplied with inside numbers and outside numbers with outside numbers. But notice that the 2 on top has a radical. The 2 on top, the 2 on bottom does not. So
It would be 14.
no, we just leave it right there. There's nothing left that can be done with this.
Nothing.
Most people don't. So check it out. I'm going to verify for you now that this is true. Okay. We just decided that this leg is 7 square root of 2 divided by 2. What's the other leg?
7 square root of 2 divided by 2.
Beautiful. Now, we said,
But that's not.
hold the thought, if we go and we want to take the leg and figure out what the hypotenuse is, what would we multiply by? The square root of 2. So let's just check that. If we take this leg and we multiply by the square root of 2, we should get back to that hypotenuse if this is right.
Right.
So what is 7 square root of 2 times, that becomes 7 square root of 4, right?
Right.
And the bottom becomes 2. What is the square root of 4?
14 over 2.
Which becomes 7 times 2 over 2, which is 14 over 2, which reduces to?
7.
And look what it, and that's exactly what we said it was.
I thought that the 7 like by itself would have to have I thought it'd have to be 7.
Okay, I'll get all the questions. Give me a second. I know you guys have a lot of questions, so Susie, first question.
Okay, why did you multiply the radical 2?
On the bottom, you are never allowed to leave
On the top.
on the top,
Yeah.
because, oh, why did I do it up here? So we realized that this was the leg. We said this was the leg. But then I wanted to prove to everybody that this is the correct answer here. And remember, in a 45, 45, 90 triangle, we take the leg, whatever it is, and multiply by the square root of 2, and you'll get the hypotenuse. So all I was doing when I did this was I was verifying that when I did that in fact it does equal 7 like we wanted it to. Because I was like, these are really weird numbers, and I'm not really sure about them. So I was verifying that it's still true. I was like, yeah, that's true. It still goes along with that rule.
I thought the hypotenuse had to be like a number square root of 2.
Right, that's what I'm saying is you get so used to seeing it there. So what about when you don't see it? Remember, if you have the hypotenuse, then you need to divide by the square root of 2 to get back to the leg. If you have the leg, you need to multiply by the square root of 2 to get to the hypotenuse. Yes, sir.
So would there be a question where like you can reduce it more after like?
Yes, I mean, I could try to come up with something, but yes, any outside numbers could reduce with outside numbers and inside numbers with inside numbers.
I'm talking about like there.
Okay, so let's just say that this was 8. Then this would have been 8 square root of 2 divided by 2, and 8 square root of 2, and this would have worked all the way over, and we would have had 8, this would have ended up, the leg, see the leg?
Yeah.
I'm just making this up. I don't want to make up too much stuff here. That 8 and the 2 there that are outside would end up simplifying to 4.
Okay, thank you.
So that can happen. It didn't happen in this
It would
one.
be 4 square root of 2 over 2.
Right. And again, I don't want to just make up too much stuff because then people go, wait, what are you doing? I'm just making stuff up to see it.
Thank you.
Okay. So again, this is very important. If you have the leg, then you multiply by the square root of 2. So it's a times the square root of 2. If I have the leg, then it is dividing, take that, whatever that is, and divide by the square root of 2. Okay. So let's give it a try here.
You would have to do that.
I don't know because they didn't even tell me what kind of triangle this is. I see a right triangle.
You
That's
don't
it.
know that the other two are 45.
There, I saw it's in there.
Keep
It's
going.
an isosceles.
It's an isosceles triangle. Great. That's a piece of information I could use.
So then,
So, since you know that number 6 is the hypotenuse, so
Yes.
you have to divide.
But how do you know this is a 45, 45, 90 triangle?
because it's because since those two are the same, because of the base angles theorem, you know that it's 45.
Good.
45.
Here's the base right here. It just happens to be on top here. So those two are the same, which means the 90 degrees that isn't accounted for is split evenly between those, making it 45 and 45. Now, Amalia, tell me what you're saying before. Now that we know it's 45, 45, 90, now what are we doing?
You divide 6 by divide 3.
Good. We're going to take 6 divided by the square root of 2. Because remember, we're going from the hypotenuse back to the leg, bless you.
Bless you.
But what is wrong with this answer right here?
Oh, we have to multiply it by the radical of 2
You can't have the denominator.
at the top and the
there.
bottom.
Good.
Yeah.
What does the top become?
It's a
Just 6 square root of
6 square root of 2.
What does the bottom become?
2.
It becomes the square root of 4, which eventually becomes 2. Now notice, here's your question right there. Look what happens to this.
That's the.
Oh, you can like.
Oh, it could be 3 square root of 2 over 2.
Yes. So outside numbers and outside numbers. Look at this. 6 is outside of a radical. This 2 is outside of a radical. So 2 goes into 2. 2 goes into 2 once. 2 goes into 6 3 times. This just becomes 3 square root of 2.
Sorry, I was excited. I was excited.
You can't do that.
They're both outside numbers.
No, but you can't do the square root of 2 to the 2.
What?
What?
The square root.
Bro, that's like crazy.
I'm not trying to trick you, but explain to me what you're saying. I'm not trying to trick you here. So like, just tell me what you're trying to say.
Alright, so I thought the answer would, like, the final answer would be 3, and then square root of 2 over 2.
Well, what this two here ended up canceling out with the 6, right? 6 halves, it becomes 3, right?
Right.
Oh, okay, my bad.
So you're good? Okay, so I'm just gonna call this leg right here 3 square root of 2. Kayla.
Would you mark it wrong if we left it as 3 square root of 2 over 2?
Oh, definitely wrong. 100% wrong, actually, because she said over 2.
Or wait, 6 square root of 2 over 2.
Oh, well then you just lost half points because you didn't reduce. It would be like this. If I left a fraction like this, I would say, yeah, that does not deserve all points because, right? Like that can be reduced.
This is a lot harder.
Yeah, it is a lot harder. And you guys are a lot smarter. You're literally in an honors class. You're in high school and you're like a few years away from attacking the world with your genius minds. So guess what? I want you prepared.
So scary.
Okay. Now there's one more special right triangle we're going to do, and that's the one we're going to see next. Now I will tell you this. I'm going to highly recommend to you, for those of you who are playing games and iMessaging and things like that, that you go and make yourself note cards or something like that for these special right triangles. Because if you don't know them, if you know them, great. You don't have to. If you're like, I can do this back and forth, but you should know, like, what do I do if I have the hypotenuse and I'm going back to the leg? What if I have the leg and I'm going to the hypotenuse? That is only for a 45, 45, 90 triangle. Usually this is the one that people think is easier compared to the other one. The other one's not hard, but people think it's harder than this one. So I'm going to move on to the next one. The next one is a 30, 60, 90 right triangle, which means that the angles inside this triangle are 30 degrees, 60 degrees, and 90 degrees. Notice here we've got a 30 degree angle, a 60 degree angle, and a 90 degree angle. In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. I'm going to give everyone a minute to write that, or like 30 seconds to write it, because what I'm about to tell you is the most important piece of information about this one, that if you're going to get this right, you need to understand one piece of information about the 30, 60, 90 right triangle that a lot of people struggle with. In the 30, 60, 90 right triangle, no matter which one you're talking about in the world, if its measures are 30, 60, and 90, there will always be a long leg and a short leg. And sometimes it's hard to tell which one is which. Even just because, the diagrams aren't always to scale, it's hard to tell which one is which. So here's the thing. There is a way to always tell which it is. I don't even need to look at the numbers, but check it out. The number 30, if I were going to look at it as a word, starts with what letter? T. It's a T. 30 starts with T, right? Okay. And the word 460 starts with what letter?
Six.
F. An F. I said it.
S.
Wait, what?
60. Okay.
What did you say?
I said
The most important part of the 30, 60, 90 triangle, the most important part, the part you care about more than any other part on here, is the short side. I promise you, if you know the short side, your life is easy. If you don't know the short side, you have to do work. So, the short side is always the leg that touches 60. See how it has an S there for short? It is the leg that touches 60. So I don't care what the numbers are. The leg that touches 60 is always the short leg.
But how do you know it? Because like I
Wait,
can get
the
confused that
shorter,
it's too late.
the shorter ankle is pointing at the shorter leg, right?
Yes, I don't think about it like that, but yes.
Because like, when we did.
I know what you're saying. I don't want to. Yes. So small angle has small side across from it. Large angle. So just like we learned, small angles have small sides across from them. So if you would rather look at it like that, the across from the 30 is the small side. For me, if I have a hard time finding where the short side is, it's always the side that's touching 60 degrees. Whatever one is touching 60 degrees, that's the short side. Okay. So this is why this is super important. If I know the short leg, if I know this number, and I want to find the hypotenuse, I just multiply by 2. So, if A is equal to 5, then what is the hypotenuse? It would be 10, because 2 times 5 is 10. Let's pretend that I didn't know the short leg, and I only knew the hypotenuse. Let's say that the hypotenuse was 10. How would I get back to the short leg? Divide by 2. We multiplied by 2 to get there. Let's divide by 2 to get back, which would tell us that A is equal to 5. That is to go from short leg to hypotenuse. Short leg to hypotenuse on a 30, 60, 90 multiplied by 2. If you want to go short leg to long leg, you multiply by the square root of 3. So, if A is 5, what is the long leg?
5 square root of 3.
5 square root of 3. Just multiply by the square root of 3. Now check it out. Let's pretend that I know the long leg. How would I find the short leg?
You divide by the square root of 3.
Divide by the square root of 3. Look at this. 5 square root of 3 divided by the square root of 3. Those will cancel, leaving me just 5. Now here's the thing. Don't try to go from hypotenuse to long leg or vice versa. Don't go long leg. It's so important that at any time you are going from the short leg. The short leg makes it so much easier. Is it possible to go to from long leg to hypotenuse and vice versa? Yes, but way harder. Let's not even bother talking about it because then people will freak out. If you know the short leg and you want to know the hypotenuse, multiply by 2. If you know the short leg and you want to know the long leg, multiply by the square root of 3. So, you can see that these numbers are different than the 45, 45, 90 right triangle. So, let's move on to the next one. Those are only 2 triangles, but now we're going to try one out. Which side of this triangle is the short leg?
5.
5. How do I know that this is a 30, 60, 90 right triangle?
Because if it's 60 plus 90 would give you 150, and then you need 30 to get to 180.
Has to be. I need 30 more to make this 180. Now, how do I find the hypotenuse?
The hypotenuse. You just
multiply by 2.
Multiply by 2. So 5 times 2. Short leg times 2. Short leg times 2. 5 times 2 is 10. Now, I want to know what the long leg is.
You
Multiply by the square root.
I didn't mean to use the same numbers as I just did. I just realized I used the exact same numbers.
That's why I got it.
But let's say that you started off right here. Let's say you started with this and they asked you to find the hypotenuse. You're still going to go to short leg.
Right.
And then just do it in a 2-step process. But you got to include short leg. I'm telling you right now, I've done this so many times that if you decide to leave out short leg, is it possible? Yes. Is it harder? Heck yes. Way harder. Because we're not even talking about simple little things there. Now you got to have this whole like much bigger formula you need to get, because you need to have both things combined into one formula there. Marcel?
I have a question for the one on the top that we just did.
Yeah.
With the 5.
Yeah. which is basically this one, right?
Yeah. How come for this one you got 5 square root of 3 as a final answer? And then for the other one you got 5?
Because on the other one, I said, what if this was 5 square root of 3, what would the short leg be? And we divided by the square root of 3. We were saying what the short leg would be. If you knew the long leg, how would you go back there? You'd have to divide by the square root of 3 to get back.
Alright. Thank you.
You're welcome. Okay, let's put this to use. The diagonal of a square has length 6. What is the perimeter of the square? So, I don't care if you know how to do this all the way through. Let's talk about what we do know how to do. Let's talk about what should we start? What's our strategy to even start this?
Draw a square.
Let's draw a square. I would do the same thing. Okay, here's a square. Let's see what's going on here. And we're going to need a diagonal, right? There's a diagonal. Now, because it's a square, I'm going to add in my right angles. There's a right angle up here and a right angle up here. What else?
These mark the diagonal 6.
Perfect. Okay, now here's kind of the part where we need to make something out of this right now. There's a piece of information in the text that we have not marked on here. Yes, sir?
So 90 degrees.
We marked that.
The 90s.
Oh, because this isn't 360.
Yes, ma'am.
It's a square, so all the sides are congruent.
Beautiful. All the sides are congruent. That's a very important piece of information.
That's smart.
Now, I'm going to zoom in a little bit because I'm guessing people will start to get it once I zoom in. Yes, sir. Go ahead.
Alright, so you know that it's a 90, 45, 45.
How did you know it was a 45, 45, 90?
Because since there's a diagonal and it's a square, it's like half of the 90.
Okay, check it. Whoa, I was almost with you there. But a diagonal doesn't have to split it in two, does it?
Yeah.
Wait, it does because they're congruent.
What's congruent?
The sides are congruent, so it's
Okay,
an isosceles triangle.
so we see that this here is an isosceles triangle. It's true on the other side too. I just picked a side. I decided lower right. You could do upper left as well. Now, I don't know what those two sides are, but this is definitely a 45, 45, 90 right triangle because we see that it's isosceles. And it's an isosceles right triangle, which means that the base angles will be congruent. I'm going to switch to a different color. That doesn't show up very well. The base angles will be congruent, meaning that this is 45 degrees and this is 45 degrees. Okay, well, how the heck does that help me? Because I'm missing a lot of information here. Yes, sir.
So you do 6 divided by the square root of 2?
Beautiful. Remember, in a 45, 45, 90 right triangle, you take the leg and multiply by the square root of 2 to get to the hypotenuse, but we're going back from the hypotenuse, so we need to divide by the square root of 2.
And then you multiply by the square root of 2 over the square root of 2.
Square root of 2 over the square root of 2.
And then the bottom, the top stays is 6 square root of 2 for now, and then the bottom would give you 2 because it would get square root of 4.
Square root of 4, and the square root of 4 is 2.
And then what you do here is you get 3 square root of 2.
So this is 3 square root of 2. This is 3 square root of 2. I'm going to make a mistake here. My final answer is 3
No,
square
the
root of 2.
perimeter.
It's the perimeter.
I got you.
So this is a very easy mistake to make because you get this victory here and you go, oh, I'm done, 3 square root of 2.
Nah,
But
you
it's
don't fool me.
thug life. All right.
Oh wait, don't you have to do 3 square root of 2 times 3 square root of 2?
No. That would be the area of the square. That would be side times side. How do we do perimeter?
Yeah.
Oh wait, you have to put them on all of them though, right?
No, you multiply by 4.
Yeah, we could just multiply this by 4, right? If we have 4 of the exact same side. Now, here's the part where some of you are still struggling, and I need you to get this because it's outside numbers times outside numbers and inside numbers times inside numbers. So what does this end up being?
12 square root of 8. You can't simplify that.
12 square root of 2.
Yeah.
12 square root of 2. Notice how many people said outside times outside, inside times. That 4 is an outside number. It only gets multiplied with outside numbers.
So you don't distribute it?
No, that's not a distributing. It was like, so it would be like this. This is just like a what if. If I had 4 times 3x, what does that equal?
12.
12x. You only multiplied the 4 with the 3, right? You didn't multiply it twice. That's exactly what happened here.
Oh, that's a great way of putting it.
Thank you. I should start teaching for a living.
You should.
You should.
I should do that. One day, like maybe I'll have my own classroom, a whole bunch of students in there.
One named
I don't know
Gio.
what you need.
That's cool.
You might have one named Gio.
All right, so my final answer is 12 square root of 2.
Yes, sir.
One more slide. Yes, sir.
Mr.
Ooh, I
Hodge,
don't
if
know.
you became a teacher, you should give all your students A's.
That sounds like a terrible idea.
Why?
I agree with that.
Prove it. No.
Okay. An equilateral triangle. What is true about an equilateral triangle?
All the sides are equal.
All the sides are equal. So I'm just going to draw an equilateral triangle, or to the best of my ability.
That was a good
Yeah, that last line was a little wonky. Yeah, as soon as you said that was good, I was like,
for the most part.
okay. Equilateral triangle. We have an equilateral triangle that has an altitude length of 5. How do I draw the altitude? From floor to ceiling. Here we go. Okay, ceiling to floor. Thank you.
Wait, that can't be. If it's equilateral, then.
It just
Oh, okay, my bad.
okay, we need to find the perimeter. Okay, so this has an altitude of 5. Now, we need to put together what we know about these triangles. Yes, sir.
Are equilateral also equal angles?
Beautiful. So what's true about the angles here?
They're all 60. Well,
This is 60.
of the big triangle.
This is, yeah, of the big triangle, this is 60. And this one up here is also 60. How is it possible that this triangle on the right there has angles of 60, 60, and 90?
Because the top one is technically 30. Cause
Yeah, it's
half-
split up. Like, even if you didn't know that was an angle bisector, you do know that this is 60. You do know that this is 90. So this has to be 30. This one has to be 30. It has to be. That's the only way triangles work. Okay, great. So now, you know what I'm going to do is I'm only going to show like half the numbers here because I only want to work with one of the triangles. So I'm just choosing the one on the right. You could choose the one on the left just so that we can focus on one part there. So let's talk about that right triangle, that 30, 60, 90 right triangle on the right. What do you got for me, Gio?
So you have to multiply the 5 by the square root of 3. I mean, you have to divide the 5 by the square root of 3.
Why would I take the 5 and divide it by the square root of 3? You're right.
Okay, that's just what you do.
What piece is this? What of the 30, 60, 90, what piece is that?
Hypotenuse. I'm
The-
sorry, not the, a leg. A leg.
Which leg?
The long.
The longer leg.
Yeah.
How did I know that that's not the shorter leg?
Because it
Because
doesn't
like-
touch 60.
It doesn't touch 60. Notice that my drawing there is like, I don't know, I can't tell which is longer, but the shorter one will always touch 60. So remember, it's the short leg times the square root of 3 to get to the long leg. So to go back, we have to divide by the square root of 3.
Exactly.
Which I don't know how to do that.
You do know how to do it.
Oh, yeah, you just multiply the square root of 3 over the square root of 3.
Square root of 3 over square root of 3. Now we did this twice with the square root of 2, but watch, same thing happens. The square root of 3 times the square root of 3 is?
5 square root of 3.
No, sorry, on the bottom. Square root of 3 times square root of 3
Square root of 9.
is the square root of 9, and the square root of 9 is? 3. The top becomes
5 square root of 3.
5 square root of 3.
My bad.
This piece right here is 5 square root of 3 over 3. Now just remember, that's this piece right here. Not the whole bottom of this triangle, just that piece.
You just multiply that by 2.
Multiply the short... Yes, sir.
I don't understand. Isn't the black side like
Yeah.
Yeah. Are you talking of this? Here, of that?
yeah?
Yes, the black side on the right is the hypotenuse.
So now you just multiply 5 square root of 3 over 3 by 2.
What do we find?
So here's the thing. Of this triangle right here, we're looking at this triangle here, is a 30, 60, 90 right triangle. This 5 is the long leg. Remember I told you that the short leg is the most important. You must find the short leg. So we went back to the short leg. Now from the short leg, we're going to go to the hypotenuse. You want to find the hypotenuse, I agree with you, but it has to be through the short leg.
But isn't the 5 the side as 2A?
No,
It's A, 2A.
no, because look at the 90-degree angle. It's pointing to the hypotenuse, right? So this is the hypotenuse right here. Okay, so now that we've got 5 square root of 3 over 3, What is the hypotenuse?
You just multiply it by 2.
By 2. So 5 square root of 3 over 3 times 2.
Which would give you 10 square root of 3
10 square root of 3
over 3.
over 3.
Which, that's it. Because you
He took the short leg. This is the short leg. And he multiplied times 2 to get to 10 square root of 3 divided by 3.
we're not done.
Okay? Because we're not looking for just a side of it. We're looking for the perimeter. So how will I find the perimeter?
What you have to do is you have to do 10 square root of 3 over 3 for the other side.
Okay, so we can label this 10 square.
And then the bottom's also 10 square root of 3 because we know that 5 square root of 3 over 3 is
Okay,
2.
so he's saying this is 10. Yes, this is all true. This is not necessarily the direction I would go, but it's not wrong.
I was gonna say like they're all equilateral.
It's equilateral, so what?
So like they're all gonna be the same.
Okay, so what should we do with that then?
Multiply by 3.
Yeah, if each side is 10 square root of 3 over 3, and there are 3 sides, then just multiply by 3. What happens when we multiply this out?
You just get 30 square root.
The 3's cancel out, leaving just 10 square root of 3. The perimeter is 10 square root of 3.
That's math right there.
That's math, math, math.
Oh, yeah.
Or if you'd rather, okay, some of you don't like that, so I can see 3 times 10 square root of 3 divided by 3. 3 times 10 is 30 square root of 3 divided by 3. How many times does 3 go into 10? Or excuse me, 3 goes into 30?
10 times.
10 times, which is 10 square root of 3. Same exact
Makes me
thing.
feel better.
That made more sense to me.
Everybody's got a way that their mind works with numbers. You see it one way or you see it the other way. So I'm willing to go like whichever way helps you out. But both of them, what I did were mathematically the same. It's just, I looked at it 2 different ways there. All right. So if it were me, I would start creating these note cards for these 2 special right triangles, like showing like in a 45, 45, 90 right triangle, that it's the leg times the square root of 2 to get to the hypotenuse, and I divide to go backwards. In a 30, 60, 90, it's all about the short leg, and I take the short leg times the square root of 3 to get to the long leg, and I take the take the short leg times 2 to get to the hypotenuse. And the short leg always touches the 60. These are notes you can start creating for yourself. So that is it. There's a lot of stuff going on there, but that is it.